Ever pondered why the moon, despite being 238,855 miles away, can still cause the waters on Earth to rise and fall? It's a question that has intrigued scientists and philosophers for centuries. The moon, our closest celestial neighbor, has an undeniable influence over the Earth, particularly over the vast bodies of water that cover over 70% of our planet's surface. This phenomenon is not magic, nor is it mere chance. It's a dance choreographed by the laws of physics, a result of the moon's gravitational pull on our planet. Just as the Earth's gravity keeps us grounded, the moon's gravity reaches across the void of space to touch the Earth. But it's not just gravity at play here. There's another force involved, a subtle yet powerful force that shapes our oceans and coastlines. It's called the tidal force. Well, the answer lies in the power of the moon's gravitational pull and something called tidal force. So what exactly is this tidal force we mentioned earlier? Well, let's imagine a tug-of-war between the Earth and the moon. The moon, although much smaller than Earth, has a considerable gravitational pull. This pull is strongest on the side of the Earth closest to the moon, creating a sort of gravitational stretch. Picture it like a balloon being pulled or stretched out on one side. This stretch is what we call a tidal bulge, or more commonly known, a high tide. Now you might be thinking, all right, I get it. The moon pulls the water towards it and we get a high tide. But why do we have 2 high tides a day? That's a fantastic question, and here's where things get a little more complex. As the Earth rotates, the side closest to the moon isn't the only place experiencing this tug-of-war. There's also a tidal bulge on the opposite side of the Earth. This happens because the Earth itself is also being pulled towards the moon, but the water on the far side isn't pulled as strongly, so it gets left behind, causing another high tide. In between these 2 high tides, the water levels drop, creating what we know as low tides. As Earth spins on its axis, most places on its surface pass through 2 high and 2 low tides each day. So the dance of the tides is really a complex ballet of gravity, Earth's rotation, and the water's response to these forces. And if you're wondering why the tides are not the same height, that's because of a multitude of factors such as the depth of the ocean, the shape of the coastline, and even the angle of the moon's orbit. In essence, the moon's gravitational pull and Earth's rotation work hand in hand to give us our daily tides. It's a beautiful example of how interconnected everything in our universe truly is. Even though the moon is over 200,000 miles away, it's still pulling the strings, influencing our oceans and shaping our world. But the moon's phases also play a part in this tidal dance, don't they? And indeed they do. Let's take a closer look at how the moon's phases affect our tides. Picture the full moon and new moon phases. During these times, the sun, moon, and Earth align in a straight line. This alignment is known as syzygy. Remember that catchy term? Now, when syzygy occurs, the gravitational pull from the sun combines with the moon's gravitational pull, and what we get are spring tides. No, not the season spring, but spring as in to leap or jump. And that's precisely what happens to our tides during these phases. The high tides are higher and the low tides are lower. We can say the tides spring up and down more than usual. Now let's shift our gaze to the first and third quarter moons. It's a different scene altogether. During these phases, the sun and moon are at right angles to the Earth. This arrangement breaks the combined gravitational pull we saw during syzygy. Instead, the sun and moon pull the oceans in different directions. This tug-of-war between the sun and moon results in neap tides. The word neap comes from an Old English word meaning without power. And true to its name, these tides lack the power seen in spring tides. The high tides are not as high, and the low tides are not as low. The difference between high and low tide is less dramatic, so you see, the moon does more than just paint a pretty picture in our night sky. Its phases play a significant role in the ebb and flow of our tides. In essence, the moon's dance with the Earth is not just a celestial spectacle, but also a choreographer of our ocean's rhythm. And this rhythm, the rhythm of the tides, is a beat that affects all life on Earth. So the moon's phases not only light up our night sky in different ways, but they also affect the rhythm of our tides. We've talked a lot about the moon and tides, but what does all this mean for us on Earth? Well, let's break it down. The rhythmic ebb and flow of the tides has a significant impact on our daily lives, particularly for those involved in seafaring activities like fishing and boating. Fishermen, for instance, often plan their schedules around the tides to maximize their catch, while sailors navigate the seas using the tidal currents. The influence of tides extends beyond human activities to the ecosystems, particularly the intertidal zones. These are areas between the high and low tide lines, teeming with diverse species that have adapted to the constant changes in water level and salinity. And there's more. Our understanding of tides could be a game changer in the energy sector. Tidal energy, harnessed from the gravitational pull of the moon, is a promising source of renewable energy, offering a sustainable way to power our future. Indeed, the moon's influence on our tides has far-reaching effects, from our daily activities to our energy resources. So there we have it, the moon's gravitational pull, its phases, and their combined effect on Earth's tides. It's a celestial ballet with the moon as the leading partner, dictating the rhythm and pace of our Earth's waters. Let's quickly recap. The moon's gravitational pull is the invisible string that tugs at our oceans, creating the tidal force that brings us high and low tides. The moon's phases, from the new moon to the full moon, influence the magnitude of these tides, leading to the occurrence of spring tides and neap tides. And let's not forget the impact on Earth. The moon and its tides shape our coastlines, influence our climate, and even affect the behavior of various species. It's a beautiful and complex relationship, one that continues to fascinate scientists and stargazers alike. Next time you look up at the moon, remember the powerful and intricate dance it leads with our Earth's waters, shaping our world in ways we often take for granted.